everybody, Mrs. Bullen here, and we're going to continue looking at guided notes for standard 21 and 22, area and parts of figures day 2, but in this video we'll look at parallelograms. So similar to what we did with triangles, let's talk about the parts, and just like with triangles, we are going to continue to talk about the base and the height. And in order to identify your base and height, notice we do have a right angle here, so we will continue looking at the 90-degree right angle in order to identify base and height. We actually have two bases. That's the new part here with our parallelogram. We have two bases, and both are the same. Two bases, and both are the same. And so looking at my figure here, I have a base on the top and a base on the bottom. Label these base and base. They're the same, so it really won't matter which one we look at. And our bases still meet at 90 degrees with our height. So the other part of the figure we have to pay close attention to is our height. And again, we can find it because we're looking for the 90-degree right angle. We can make a note that these two, our bases and our height, must be, and I'm going to use a perpendicular symbol again, they must be perpendicular or they must meet at a 90-degree right angle. So these are the parts of a parallelogram. We could label this our height. And then let's also talk about area of a parallelogram. So if we wanted to find the flat surface inside our parallelogram, we'd be saying area equals, and consider the other formulas we know. So for a triangle, we said we do 1/2 base times height, because a triangle takes up half the amount of area or half the flat surface of a rectangle. And if you look at this parallelogram, it looks like a rectangle, right? It looks like a rectangle, but it's slanted, right? The two sides are slanted. So I'm going to use some little dashed lines here to show you. Here would be a rectangle if we did base times height. And if we took this little piece here of the parallelogram and moved it over here, we would again have a rectangle. So a parallelogram uses the same area formula, base times height, as a rectangle does. Because you can use the base dimension and you can use the height dimension. It's just slanted. Your whole figure is slanted. And that's why you have to be very careful and make sure that you're using the height that's perpendicular to your bases and not whatever distance, side distance might be over here on this diagonal. So we'll see what that looks like when we jump into example C. So in example C, we have a figure and we need to find the area. We have our formula right here, area equals base times height. So first, let's let our eyes go right to the 90-degree right angle. So the 90-degree right angle can show me my base and my height. So here I see the right angle. So these have to be my two bases. And here's my height. It's perpendicular to my two bases. So the height that I'm using is 3 meters. And again, my bases are the same, right? So it doesn't matter which one I use. I'm going to use 5 meters. So I'm doing area equals base times height. And because I know both of those dimensions, I can simply just plug them in, right? I know my base is 5. So I'll have area equals 5 times my height, we said, is 3. So I'll plug in 3 for my height. And then I'm simply doing 5 times 3. And I get 15. Consider we were doing meters times meters. So that's how we have square meters for my area. If we look at example D, it's a little bit more confusing to look at because the area that we're finding is the area for inside this parallelogram. So here's the flat surface we're trying to find. And notice, just like how we had with the triangles, we have some dashed lines outside of our figure to help us find the 90-degree right angle because our bases and our height have to be perpendicular. So that means here are my bases for 6, and then my height has to be perpendicular. So right here is the 90-degree right angle. So this would be my height. Notice I'm not using this diagonal piece, 7.2. This would be a side length. Like if I was going around the parallelogram to add up the 4 sides here to find the perimeter, I'd be doing like 6 plus 7.2 plus 6 plus 7.2. This 6 kilometers is outside of the figure, and this is to help me recognize that my height, which is perpendicular to my bases, is 6. So again, I'm doing area equals base times height, and we said we know our base. Our base is 6, so I can plug in 6 for my base. I'm going to multiply it by my height, which we know our height. So I'm going to also plug in 6 for my height. So 6 times 6 gives me 36, and I'm going to have square kilometers. At this time, you've got U tries 3 and 4. Go ahead and pause the video. On U try 3, my bases were each 7, and my height, which was perpendicular to my bases, was 4.9. So for my area, I got 34.3 square kilometers. For U try 4, notice I was finding the area or the flat surface inside this parallelogram, and these dashed lines were here to help us find the perpendicular height that we needed to use. So our bases were 6 and our height was 1.9. So our total area is 11.4 square miles.